Now once we have studied light and ray optics and wave optics, we have come to a new chapter, and that is modern physics. And the first thing we are going to study is the dual nature of light and matter. When we say dual nature, what does it mean? Two natures. So light has got two natures, matter has got two natures. Now what are these two natures? We have to understand. The nature consists of two types of things. Number one is material, what we are able to see, which has got mass, which has got volume, which can be seen and which can be thrown and it will go like a bullet. It has got a finite volume, it has got a shape, and it will go with a finite mass and with a finite energy. The other, this is material, we call it matter. Finite energy, mass, shape, and this moves in a straight line. Okay, it has got dimensions. So, if I am holding a stone and throwing it towards you, it has got certain mass and half mv square energy. Then it has got certain volume. You can see this. This is a matter. Now, other thing in this nature is radiation. Radiation, the best example, light, heat, radio waves, X-rays, all these are radiations which as such we cannot have the dimensions and which do not have any particular shape, which we can see like they have got shape. So radiation is not having a particular shape, but when it moves, we know that it propagates in the form of waves. So radiation has got wave nature, and in wave nature, what do we have? We have propagation of energy. That was also here. But here, the energy was contained in one packet. If I am throwing this to you, it has got energy half mv square. Only that much. When it reaches you, you get that energy half mv square. उतनी एनर्जी आपको मिलती है, उससे ज़्यादा नहीं मिलती है. ओके, वेव में क्या होता है? आप धूप में खड़े होइए, धूप आती जाएगी, आपको एनर्जी मिलती जाएगी. तो वेव आपको लगातार एनर्जी देती है. यस, सो it has got a continuation of energy. Continuation. While the matter has got energy in packets. Energy okay. Now these waves are also having wavelength, frequency, certain velocity, like our radiation, light, heat, all these are electromagnetic waves, and they travel with a velocity of 3 into 10 to the power 8. That is their velocity. So these are characteristics of waves and characteristics of matter. Here the characteristic what we are concentrating more is that matter has got a packet of energy, a finite energy which is in packet. Finite. While wave has got continuation of energy. Okay, the other meaning of this is, if I throw this one chalk to you, it will have certain energy, half mv square. Suppose that energy is 5. Now I throw another chalk, then I throw a third chalk. How much energy you get? You get energy of 5, or you get energy 10, or you get energy 15. But I cannot give you the energy equal to 12. Either I can give you 5, or I can give you 10, or I can give you 15. I cannot give you 6, 7, or 11, 12. So energy comes in packets. But in case of waves, this much energy, this much energy, this much energy, this much energy. So in the wave you get continuation of energy, and here you can get the energy 0, 1, 2, 3, 4, 5, 6, all the values. So in waves you get the energy in all the values, while in matter you get energy in packets. This is quantization of energy. So in matter you get energy in quantities, fixed quantities of one particle. In waves the energy should come continuously, and it is increasing gradually. So here energy is increasing gradually. Here the energy is increasing one step, other step, other step, other step, this way. So this is quantization, energy packets. This is a property of matter. The continuous energy increase, this is property of waves. Now, by the end of 19th century, around 1890 or so, the wave theory had established itself, because it used to describe the beautiful phenomena like phenomena of interference. You have seen dark, bright, dark, bright, dark, bright, dark, bright, dark, bright. These fringes, interference pattern. This is made in the lab, and this was explained with the help of wave nature of the light. Similarly, we have diffraction. And in this diffraction, we see this central maxima and other maxima or minima. This width is more than this, and many other phenomena based on diffraction. Many medical machines were made on the basis of diffraction. Then we see another wonderful formula, that is dispersion of light. The white light is converted into red to violet, the complete spectrum of 7 colors. This is because of the wave nature of the light, and different wavelength of the lights are deviated by the different angle in a prism. So on the basis of this we explained that why a white light is dispersed into colors. And all these things we see in the lab, and all these phenomena we explain on the basis of wave nature. So by the end of 19th century, around 1900, wave theory was reigning supreme. Everybody agreed that light is a form of wave and nothing else. Till we had a phenomena. And that phenomena could not be explained. That phenomena was ultraviolet catastrophe. According to wave nature of light, the energy should keep on adding up. Now, if we go for energy for the different wavelengths, for the different frequency, the wavelength go on reducing. The average energy absorbed by a black body goes on increasing. So, this is a black body phenomena. And this says that if we are reducing the wavelength on a black body, its energy will go on increasing and its temperature will go on increasing. Then, if that wavelength is as small as ultraviolet, beyond the range of our seeing, if it is that range, that is beyond say 400 nanometer, okay, it is less than that. If it is less than that, it is ultraviolet, and ultraviolet should give it so much energy that the temperature should rise to a very, very high point, and at that time the nature or the universe should burn out. It should be such a high temperature. But in practice we see it does not happen. According to wave theory, it should happen. Okay, when we are making the graphs and doing that. But here our topic is not ultraviolet catastrophe in black bodies, but it has a importance because it has a turning point. When, according to wave theory, it was explained that ultraviolet light on black bodies will rise its temperature to infinitely high temperature, and the universe should burn out. In practice, it does not. Why it does not? According to wave theory, it should have a very, very high temperature, but practically it does not have that high temperature. Why it does not have that high temperature? And when we see the energy graph, lambda and energy intensity, we find that when we decrease lambda for a black body, the energy goes on increasing, but after a certain level we find that it again we decrease the lambda, but energy decrease. This portion, that energy decrease when we are decreasing lambda, could not be explained by wave theory. First, we are decreasing lambda, the energy intensity of the light is increasing. After a certain point, we find we are again decreasing lambda, but the energy goes on decreasing. It does not increase anymore, otherwise it should have increased so much. Very high energy, very high temperature. It does not happen. So, this phenomena was known as black body ultraviolet catastrophe, and this could not be explained. In the year 1900, there was a scientist, Max Planck, who tried to explain this phenomena, that why this happens and energy become less even when the lambda is decreasing. And for explaining this catastrophe, he put forward a new theory. And that new theory was that the light travels in the form of packets of energy, which has got finite energy packets. And this theory, this quantity of energy in a particular packet, that packet he named as quanta. Later, it was taken as quantum. Okay, so that packet of energy is thrown one after the other, and the energy given to a body where the light is falling is not continuous in nature. It will not go on increasing, but it is given in the steps like this. And one packet of energy can give energy to the material, to the electron, will be as much only whatever is contained in that packet. That energy will not be added by another packet. No. So maximum, how much energy can be given? Maximum energy given to the matter at one location is the energy equal to one packet only. That is why when we decrease lambda, the frequency increase. There is a relation between lambda and frequency. We all know that frequency is equal to C upon lambda. When we decrease lambda, frequency of the light increase. So he say, when we decrease lambda up to certain point, the frequency increase, and that energy, that photons or quantum's energy, that is the maximum energy which can be given to a material, not more than that. So energy cannot increase beyond a certain level. He gave certain explanation. So we are not studying that also. Just we are taking a reference that in the year 1900, for the first time, Max Planck gave a theory that the light comes in the packets, and one packet has got a quantity of energy, a measured quantity of energy. Each packet of energy, each packet of this energy has got vibrations in it. That vibrations is frequency. What we call frequency in the wavelength, same frequency. That frequency decides the color of that quantum. Color of that quantum, because it was quantum or quantity of light, that was also given the name photon. So he said light comes in quantums, the packets of energy, and in that energy is vibrating. It has got a frequency, and that frequency decides its color. Now, one quantum has got a fixed value of energy, and that value of energy, he said, that value of energy is h multiplied by frequency. This is a whole number multiplied by h multiplied by frequency. This is energy of a quantum. This is a constant which was later named as Planck's constant, h. What does it give? It gives n is a integral number, h is the Max Planck constant, and f is the frequency of that energy which is inside that packet. Now, what should be the unit of h? Energy number hf. So h is energy upon frequency. This is frequency is per second, so this is joule second. So h is Planck's constant, joules second, and joule second is energy. Joule is energy. Okay, so that idea was given by Max Planck, and with that he was able to explain the Blackbody ultraviolet catastrophe. He sent this idea, this explanation to all the scientists over Europe, the scientists all over the world, that this is the explanation and this is how light travels. This is light in the terms of packets, but there was no takers of that theory. उस थ्योरी को मानने के लिए कोई तैयार नहीं था कि लाइट वेव के फॉर्म में नहीं जाती. क्यों? Because we had so many beautiful examples which have been proved in the nature, which we see in the lab, that light travels in the form of waves. Everything we explained in the form of wave except ultraviolet catastrophe. Okay? But Max Planck said, no, it goes in that. The other scientists say it is only your mathematical jugglery. And nobody agrees to that, and that theory was sent to waste paper basket. So, no scientist was ready to buy it, to consider it, except it impressed one scientist, or say one person. He was not even a scientist by that time. It impressed one clerk in Registry Office of Sweden. And that clerk was Albert Einstein. This theory impressed him. And he said, yes, the light consists of packets. It goes in the form of quantums, that is photons, and when it goes and strikes the atoms of a material, they give their energy to those electrons which are on the atoms. When they give their energy to the electrons, then electrons are ejected out. With the help of those energy by the photons, some work is done. वो जो फोटोन आएगा पैकेट, वो एक फिनिट एनर्जी लेके आएगा, एक क्वांटिटी ऑफ एनर्जी लेके आएगा, और वो पूरी क्वांटिटी वो उस इलेक्ट्रॉन को दे देगा. उस एनर्जी के कारण वो इलेक्ट्रॉन अपने एटम की सरफेस को छोड़ देगा. ये एक फोटोन आया, that is a packet of energy which has got h nu energy. इसने आकर इसको हिट किया और इसके कारण ये अपने एटम से बाहर निकल गया. ये जिस मटेरियल के अंदर है उस मटेरियल से बाहर निकला, उसको बाहर निकलने के लिए कुछ एनर्जी लगी, बाहर निकलने के लिए कुछ एनर्जी उसकी कंज्यूम हो गई. उस एनर्जी को आइंस्टाइन ने नाम दिया वर्क फंक्शन. और उसके बाद जो एनर्जी बाहर निकली, उस एनर्जी को आइंस्टाइन ने कहा कि वो एनर्जी इलेक्ट्रॉन के पास है और इलेक्ट्रॉन उस एनर्जी को यूज करता है एज इट्स काइनेटिक एनर्जी. इलेक्ट्रॉन आपकी तरफ ऐसे आ रहा है, इट हैज गॉट सर्टेन मास, इट हैज गॉट सर्टेन वेलोसिटी, सो इट हैज गॉट एनर्जी, काइनेटिक एनर्जी. तो एक बड़ा फेमस इक्वेशन उन्होंने बनाया, दैट काइनेटिक एनर्जी which is coming out from a metal. See the situation again. There is a metal, a light is incident on it, and we see one electron comes out. This electron comes out. Einstein say this electron which will come out, it will have certain kinetic energy. We understand? Because it has mass, it has velocity, it has kinetic energy. He said that this kinetic energy is this energy is H frequency of that photon minus phi. This phi is work function. This is energy of photon, and this was given by equation of Max Planck. So this is the famous Einstein equation of photoelectric effect. That means when a light falls on a metal an electron is ejected out, and we can notice that electron with certain experiments. We will see those experiments. It comes out, it has got a kinetic energy, and how much is the kinetic energy? That is given by this equation. Here H is the Planck's constant, and this Planck's constant is what? This Planck's constant gives the energy of a packet. That means energy or the light travel in the form of packet. This was also agreed by Einstein, and that is a material nature. So, because of this photoelectric equation, Einstein got the Nobel Prize. Yes, that is also a wonderful thing. The Nobel Prize, one Nobel Prize, Einstein won, and that Nobel Prize was due to this equation and not due to his famous equation E is equal to mc square. This is more useful and much more famous equation, but the Nobel Prize was not given to Einstein for that equation. It was given to him because of this equation. Okay, so this proved that light has got nature. Then after this, there was a very famous experiment which we are going to study, and in that we studied that how the things which are happening, photoelectric effect which is happening, the photo which is coming, light which is coming to metal takes out one electron which has got kinetic energy. How this takes place we will see in one experiment. And there was no explanation by wave theory. The results what we got by this experiment, photoelectric experiment, were contrary to wave theory. Contrary to wave theory. This says there is nothing as wave front. Whenever there is a strike with a surface, there is nothing as wave front. These are only photons. The particles are striking a material. There were many proofs of that. They say when a wave is coming, here is a metal, here is a wave, red light. Okay, it is giving energy to the electron. Electron is not coming out. We say energy is insufficient. Okay, give it more energy. We gave that energy for half an hour, for 1 hour, for 2 hours. Electron did not come out. That means this our fundamental, that a light has intensity and wave has got continuous intensity of the energy, and that energy will go on gathering on it, and one time will come when electron will come out. That never happens. Electron never comes out. And for the second time we use a blue light, a laser, a small laser of blue light. The moment we switch on the laser and the light goes there, electron comes out. In how much time? 10 to the power minus 6 seconds. In such a small time the electron comes out. That means the wave do not have a continuous energy nature which will gather up the energy. That means the light is only in a particle. The particle of blue light has got sufficient energy which will eject the electron. The particles of red have not sufficient energy to take out the electron. Once you give one red, wasted. Give another red, wasted. Give another red, wasted. So, if I need a force of 20 Newton, or say, if I need 100 joule energy to lift it, then unless I have 100 joule, I cannot lift it. One body comes, he has got 80 joules, could not lift, waste. Another packet comes, 80 joules, cannot lift. Another packet comes, 80 joule, does not lift. So in this way we are sending red packets of energy. Each has got 80 joule, 80 joule, 80 joule. None of them can lift an electron. Then we send one packet, only one packet of blue. which has got energy equal to 120, it will go lift it up and it goes out. This we can explain with help of packet of energy. But if we say a wave continuous is coming carrying energy, then red should carry energy 80, another 90, 100, 20, 150 energy should gather in the electron. It should come out. Practically what we see, it does not come out. So there wave theory failed and the matter theory passed because we could show it. Other very famous experiment was at the same time being done by Rontgen in Germany, and that was when an electron hits a metal, it is absorbed and a photon is created. A photon यानी that is a wave. एक वेव वहां से पैदा होती है जब एक इलेक्ट्रॉन हिट करता है. तो इलेक्ट्रॉन के हिट करने से एक पैकेट निकला एनर्जी का और उस पैकेट को हमने नाम दिया एक्सरे. ओके, फिर दूसरा इलेक्ट्रॉन गया, दूसरा पैकेट निकला एक्सरे. उस इलेक्ट्रॉन की हम जितनी एनर्जी फिक्स करते हैं, एनर्जी ई, okay, so electron with a fixed energy that goes to the metal, strikes it, and after that strike a wave comes out. We call it wave, we call it energy that comes out. What we call it? X-ray. That X-ray has got a fixed frequency and not a distribution of energy. Had it been a wave, or when one electron goes there and hit the other electrons, we could have got a large number of waves, just like a bell. आपके पास एक घंटी है और इस घंटी को आपने यहाँ पर हैमर से स्ट्राइक किया. यहाँ पर जैसे ही आप हैमर से स्ट्राइक करेंगे इसमें से वेव्स निकलेगी, कुछ ऐसी, कुछ ऐसी और कुछ ऐसी. किसी की वेवलेंथ छोटी, किसी की वेवलेंथ बड़ी, किसी की वेवलेंथ बहुत बड़ी. एंड व्हाट यू हियर इज ए कॉम्बिनेशन ऑफ साउंड विच हैज गॉट ऑल द फ्रीक्वेंसीज. उसमें सब फ्रीक्वेंसी होती हैं. वैसे ही हमने एक इलेक्ट्रॉन से एक मेटल को हिट किया और हम क्या एक्सपेक्ट करते हैं कि उसमें से वेव्स निकलती हैं. वो वेव्स में सब तरह की फ्रीक्वेंसी होंगी, पर होता नहीं. हमने क्या देखा कि हम जितनी एनर्जी देके इलेक्ट्रॉन को भेजते हैं, एग्जैक्ट उतनी एनर्जी के ही वेव्स, उतनी एनर्जी की ही उसमें से वेव्स निकलती है, एक पर्टिकुलर फ्रीक्वेंसी की. अगर इलेक्ट्रॉन की एनर्जी हम बढ़ा देंगे, इलेक्ट्रॉन की एनर्जी क्या होती है? ईवी. जितने वोल्ट से इलेक्ट्रॉन को एक्साइट करके हम भेजेंगे, ये उसकी काइनेटिक एनर्जी में कन्वर्ट होगी, ये जाकर हिट करेगी और ये हमको जो फ्रीक्वेंसी मिलती है, दिस फ्रीक्वेंसी इज ईवी अपॉन एच. ये एक पर्टिकुलर फ्रीक्वेंसी हमको मिली, ना तो उस फ्रीक्वेंसी से कम ना उस फ्रीक्वेंसी से ज़्यादा. फिर हमने क्या किया? वोल्टेज बढ़ाकर इलेक्ट्रॉन की काइनेटिक एनर्जी बढ़ा दी. अब उस काइनेटिक एनर्जी से फिर जब हम हिट करते हैं, फिर हमको एक्सरेज मिलती है और इस एक्सरे की फ्रीक्वेंसी पहले वाली एक्सरे की फ्रीक्वेंसी से ज़्यादा होती है. फिर एक ही तरह की फ्रीक्वेंसी मिलती है, वो ज़्यादा वाली. इसी तरह से अगर हम इलेक्ट्रॉन की एनर्जी कम करते हैं तो कम फ्रीक्वेंसी वाली एक्सरे मिलती है. उस समय उसके अंदर मिक्स होके हमको स्पेक्ट्रम नहीं मिलता है, कम और ज़्यादा वाला. तो इसका ये मतलब है इलेक्ट्रॉन की एनर्जी और फ्रीक्वेंसी जो एक्सरे आई उसकी फ्रीक्वेंसी में डायरेक्ट रिलेशन है, एम्पलीट्यूड में नहीं है. और वेव क्या कहती है? इंटेंसिटी एम्पलीट्यूड में होती है. और मैक्स प्लैंक का क्या कहना था कि कि ये पैकेट होता है और उस पैकेट की एनर्जी फिक्स होती है और वो एनर्जी h न्यू होती है, न्यू उसकी फ्रीक्वेंसी है और ये एनर्जी है जिसका एक्सचेंज हुआ। एंड दिस इज द फेमस इक्वेशन फॉर एक्स रेज। इसमें वर्क फंक्शन नहीं है। क्यों? क्योंकि फोटोन का मास नहीं होता और हम ये मानते हैं कि उसको मेटल में से निकलने के लिए कोई खास वर्क करने की एनर्जी की जरूरत नहीं पड़ती, तो इलेक्ट्रॉन की पूरी एनर्जी फोटोन की फुल एनर्जी में कन्वर्ट हो जाती है। सो ये जो फिक्स फ्रीक्वेंसी बाय इलेक्ट्रॉन एनर्जी जो निकली एक्सरे में, इसका एक्सप्लेनेशन वेव थ्योरी से नहीं हो पाया। किससे हो पाया? क्वांटम फिजिक्स से, that there is a quanta, there is a photon which has got a fixed energy and which moves, which behaves like a matter. इसी तरह से और भी एक्सपेरिमेंट्स हुए जिन्होंने प्रूफ किया कि लाइट में जो एनर्जी होती है that is because of fixed quantities. And with that there was all confusion because the scientists were not ready to leave the wave theory. वेव थ्योरी को छोड़ नहीं सकते। क्यों? इसलिए नहीं छोड़ सकते क्योंकि इंटरफेरेंस पैटर्न अभी भी है, डिफ्रैक्शन अभी भी है और डिस्पर्शन इनटू 7 कलर्स अभी भी है और इसकी एक्सप्लेनेशन क्वांटम फिजिक्स के पास नहीं। सो इसकी एक्सप्लेनेशन सिर्फ वेव थ्योरी के पास है। तो वेव थ्योरी तो है। अब इसका सॉल्यूशन क्या था? सॉल्यूशन था दैट लाइट हैज गॉट टू नेचर्स। इट हैज गॉट ए वेव नेचर and because of the wave nature it is showing these phenomena in the nature, and the light has got particle nature and because of that particle or that matter nature it was showing the phenomena of ejection of electrons, that is photoelectric effect. It is because of that phenomena it was showing a fixed frequency X-rays when electrons are hitting. So light has got both the natures. Now in which nature light is? How can we find the light in one nature or the other nature? The answer is we cannot do this. Light decides itself. We can only observe it. And what have we observed? We observe that when the light is traveling in one single medium, then it has the nature of wave. It shows all the phenomena of waves. तो जब लाइट एक मीडियम में जा रही है तो वो वेव नेचर दिखाती है ये इस तरह से। लेकिन ये लाइट जब किसी दूसरे पार्टिकल को हिट करेगी एब्जॉर्ब होने के लिए, तो जब ये स्ट्राइक करती है तो ये अपने आप को चेंज करके अपना नेचर कैसा बना लेती है? मटेरियल जैसा, जैसे गोली हिट करती। So when it strikes a surface, it takes the nature of particle. When it moves in a medium, no striking, then it propagates like a wave. The moment it strikes material, and from wherever it starts, like in the case of X-ray, we sent one electron, it started light. When it starts at the source, it is in the particle nature, then in the medium it comes out in the wave nature. Because of this wave it is showing interference, diffraction, different colors, and again when it strikes a surface it shows the material nature. So at the source and at the strike point it is showing particle nature, material nature, photon nature, and when it is traveling freely in a single medium it shows wave nature with all these phenomena. And you will find that all these phenomena are this when it is traveling in a medium. when it is traveling. So, but when it strikes and there is a conversion of energy, then it is particle nature. Another fact, that light can adopt both the natures, but at any one time it will have any one nature, not both. So light at any time will be either a particle or light at that time will be a wave, but it will not have both the nature at the same time. एक टाइम में सिर्फ वो एक ही तरह का नेचर शो करेगी, और जब वो वेव है तब वो पार्टिकल नहीं है, और जब पार्टिकल है उस समय वो वेव नहीं है. So you cannot have both the phenomena at one place. It is either this or that. So this is a basic commentary what is meant by dual nature. तो ये dual nature होता है लाइट का. वैसे ही जब ये चीज़ से ये सब चला, एक्सप्लेनेशन हुए, 20-25 साल लगे, उस समय एक और साइंटिस्ट थे जर्मन, डिब्रॉय ने ये कहा कि इस यूनिवर्स में हर चीज़ हमारे नेचर में सिमेट्रिकल होती है. तो अगर रेडिएशन के पास दोनों नेचर हैं, वेव का भी और मटेरियल का भी, तो जो हमारे पार्टिकल चल रहे हैं, जैसे कि सबसे छोटा पार्टिकल इलेक्ट्रॉन, तो वो जब चलता है उसके पास भी दोनों नेचर होने चाहिए. जब उसको ज़रूरत पड़े पार्टिकल नेचर यूज कर ले, जब उसको ज़रूरत पड़े वेव नेचर यूज कर ले. ऐसा होना चाहिए. बिकॉज वाई? विद ए सिंपल रीज़न, नेचर लव्स सिमेट्री. नेचर को सिमेट्री पसंद है. उसने एक सेट ऑफ लॉज जो बनाए हैं रेडिएशन के लिए, वही सेट ऑफ लॉज किसके लिए होने चाहिए? मटेरियल के लिए. अगर रेडिएशन के पास दोनों नेचर हैं, वेव नेचर भी और पार्टिकल नेचर भी, तो मैटर यानी इलेक्ट्रॉन के पास भी दोनों नेचर होने चाहिए. तो उसको वेव नेचर में भी चलना चाहिए इलेक्ट्रॉन को, और जब वो वेव नेचर में चलेगा तो उसके पास वेवलेंथ भी होगी, उसकी फ्रीक्वेंसी भी होगी, वो इंटरफेरेंस भी करेगा, डिफ्रैक्शन भी करेगा. क्या वाकई करेगा? मालूम नहीं था उनको करेगा कि नहीं करेगा. He could not show it in his lifetime, but later it was proved कि ऐसा होता है और इलेक्ट्रॉन भी ऐसा कर सकता है. And then it was proved that electron, which we see as a material, is also have got both the natures. It can travel in waves, it can do the interference, it can do the photoelectric effect. Photoelectric effect हमने देखा, एक्सरे बनाता है इलेक्ट्रॉन. इलेक्ट्रॉन हिट्स, give all the energy according to this equation, E is equal to H naught, और उससे E is equal to H naught, उससे जो फोटोन निकलते हैं एक्सरे के. और इलेक्ट्रॉन को हमने एक दूसरे एक्सपेरिमेंट में भेज के देखा, उसने इंटरफेरेंस पैटर्न भी बनाकर दिखाया हमको. दोनों काम वो कर सकता है. सेम रूल्स फॉर बोथ. सो it is not only radiation which has got dual nature, it is material, that is electron, which is also having a dual nature. So that is the chapter, dual nature of light and matter. अब इसको हम किस तरह से स्टडी करेंगे? For our class we have a very small portion of this quantum physics. This is quantum physics because we say the energy goes in quantas, and this start with this. So we will make our study. First we will study that particular experiment which has proved that light goes in photons, and there are certain phenomena which could not be explained by wave nature. That we will study, and then we will study one experiment for electrons which will show that electrons are able to give diffraction pattern. So we have seen wave nature of light. Now we will see the material nature of light, that it comes in photon. So this experiment we will see in the next lecture. Thank you.